We've put together a simple console application that we're going to use to demonstrate the value that domain events can have in your application. The idea behind this is to strip things down to as small a level as possible. Then, we'll also show how domain events are playing a real role in a more real-world way when we get to our veterinary scheduling application. This is a .NET console application with dependency injection. The main program just loads the needed services and runs the app. The app has a simple run method which goes through the following steps. We can step through it with the debugger so you can see the output in real time. The app loads services and starts running. It shows what happens when an appointment is created using a service. The service calls a factory method that creates the appointment. After instantiating the appointment, the factory method sends an email, which you can imagine includes code like what is in the comments here. Then it similarly sends a notification to the user interface, again with code like what's in the comments, before finally returning to the service. The service then saves the new appointment in the database. Then, the app creates a different appointment and saves it directly using a repository instead of a service. And once more, the notifications and the save occur in the same order. Finally, the appointment is confirmed, which triggers some UI notification, and then that change too is saved. The main thing to take away from this example so far is that the appointment class has a lot of concerns. The act of creating an appointment, especially, involves a lot of code that could fail. It's also worth noting that notifications and emails are going out before the state of the entity is saved. So if something goes wrong, users will have been told the operation was successful, and people may have been notified via email, when in fact the update itself might never go through.
The reason we're showing the behavior both from a service and with the appointment directly is because our domain should be designed to work either way. Earlier in this course, when you learned about domain services, we explained that forcing all operations on your domain to go through a set of services tends to lead to an anemic domain. Ideally, your aggregates and entities should behave correctly whether they're being used directly or through a set of services. One way we could improve this design would be to move the responsibilities of actually sending emails or updating the UI to helper methods or other services. Then we could call them from appointment.create instead of having all the code in here. This would make for less code inside of appointment.
That would definitely be better, but it would still mean that appointment would need to be updated every time a new requirement came along. There's a principle we can use to avoid that, though, called the Hollywood principle.
I love the name of this principle. Its name comes from an old saying from Hollywood agents, "Don't call us, we'll call you."
Exactly. Applied to software, the principle is closely related to dependency inversion from Solid. Instead of forcing appointment.create to have to know about and call every possible thing that might be involved in the appointment creation workflow, instead, it can just let the app know something happened and let the app respond by calling handlers.
Instead of putting all the logic into this method, potentially making it huge and complicated and really hard to read, we move that logic into handlers, and the app calls the handlers. We don't call the handlers, the app calls us. And beyond just reducing the amount of code and responsibility inside appointment, this approach also lets us make sure that notifications to the user don't occur until persistence is successful. And it still keeps the model's behavior consistent without requiring a service to perform any of the work. Let's see how it works.
Domain events is a pretty simple pattern, but you do need to have some plumbing code to support it. You also need to think about whether you want your events to fire before or after persistence. In many cases, what you really want is post-persistence events, for the reasons we mentioned above. You want to make sure your persistence succeeds before you send any notifications outside of your app. Also, although occasionally I've used them for validation in the past, ideally your domain events and handlers should never fail. That is, don't build your behavior around exceptions that might be thrown from event handlers. Use a different pattern if you need that type of behavior.
In this simple demo, which mirrors how our sample app works, we just need a collection of events on each entity. We're creating simplistic types to represent domain events and their respective handlers. You can implement the logic to find and call handlers whenever an event is dispatched in a number of ways. For this sample, we're using the Mediator NuGet package created by Jimmy Bogard. Steve mentioned that you'll need some plumbing to start, and that plumbing is the interfaces, or base classes if you prefer, for handler and domain event classes. In our example, we're using interfaces. Here's the iDomain event interface and the iHandle interface.
Once you've set up your event and handler interfaces, or base types, it's time to create some events and their associated handlers.
For this scenario, there are two things happening. An appointment is scheduled or created, and an appointment is confirmed. An event is something that already happened, so we name our events in the past tense, and we have appointment created and appointment confirmed. The event classes are pretty simple and just include the instance that triggered them, so handlers have access to any properties they might need from it. Once the events have been defined, you just take each individual responsibility out of the original method and create a separate handler for it. It's fine to have multiple handlers for the same event. Ideally, your design shouldn't depend on the order in which the handlers execute. But if it does, you could think about adding a sequence to your handler interface and ensuring they're called in sequence order.
The last thing you need to do is register or record the events on the entity. In this sample, that just means adding them to the list of events that are on that entity. The actual implementation for dispatching the events is done in the repository after the save is successful, and in our veterinary sample, this work is done in the dbcontext SaveChanges method.
Let's step through the code again now that it's using domain events.
The app starts up as before. We enter the appointment.create method.
And look how much smaller that method is now.
Definitely. It's way easier to see what's going on here. Now the domain event is added to the collection, but notice that when we step over this, nothing actually happens yet.
Right, it's just holding it until after the entity is persisted.
Which is now. Notice that we're in the repository save method, and for every event that we have stored on this entity, we're using Mediator to publish it at this point in time.
This is still in process on the same thread. There's no out-of-process queue or anything involved here.
Right, there's nothing to install using this pattern except for Mediator, and that just runs in memory. And of course, you could wire this up with your own code that simply loops over your set of events and then dispatches out to your handlers. There's nothing that says you have to use Mediator. Notice in the output that the database save occurred and then the UI and email notifications.
As expected, we only triggered side effects outside our domain after persisting. Now let's see the version that uses the repository directly and doesn't bother going through the service.
We basically see the same behavior: database save, UI, email.
All that's left now is the confirm and save, which should look similar. Entity saved, and then the UI is updated.
That's basically it. I created a small GitHub repo, which has just this sample in it. It's at github.com/ardalis/domain-events-console. There's a branch there showing how things work without events. Of course, you can also download it from the course details.
If you want to start your solution with all of this plumbing already in place, you can use Steve's Clean Architecture Solution template, which is also on GitHub. He is one productive guy. Everything shown here is already in place in the template, which is designed for you to use as a starting point for your app.